Good morning, sir.
Good morning.
Sir, we will start by in couple of minutes. Participate are joining in a short time.
Fine.
Okay, sir. Good morning to everyone, and welcome all participants to the third day of the FDP titled New Age Infrastructure, their Analytical and Design Solution, organized by Department of Civil Engineering, Marwadi Education Foundation, and AICT. So it's my really extreme pleasure to introduce today's expert of the first session, Dr. Ankur Bhogayata, sir. So sir is working as an associate professor and head of the department at Civil Engineering Department, Marwadi Education Foundation, Rajkot. Ankur sir have completed his MTech from the BITS Pilani and PhD certified international engineering educator. Sir has more than 18 years of teaching and research experience and also He's associated with the ACI and ISTE and also advisor to the ACI Indian student chapter at Marwadi University, Rajkot. He is one of the key personality in the university who is actively involved in a field of the research and innovation. And sir has also guided more than 25 PG students and 9 PhD students. Sir has 3 patents and many funded projects from the SSIP government of Gujarat state. Sir has published many number of the research paper in WIS, Scopus Index Journal with a total citation of the 217 with a H Index 8 and H10 Index 8, and with a 3 ebook chapters published with the Elsewhere and Springer, and also published on a book with a Tata McGraw Hills publisher India. So it's we can see that it's a very rich research profile sir has, and also sir is associated as a role of the reviewer in the Elsewhere, Springer, and ACR Journal. So with this, I request sir to take the session forward. Welcome, sir.
Thank you, Hussein, for such a nice introduction. With this, let me straightforward go to the session. Let me try to share my screen. I think you
Yes,
have.
sir, you can share your screen.
All right. So I hope it's visible.
Yes, sir.
Yes, sir, it is visible.
Yeah. So once the slide is on, it's irrespective that whether the speaker is visible or not practically, because there is a load shedding for a minute. So I request all the participants for bearing with this inconvenience. So I'm thankful to ATAL Academy and AICT and my own department and my colleagues for giving me this opportunity to share whatever I know with the best of my capacities. It's a good platform to share your information largely, and it's again a wonderful way of discussing a couple of recent developments in the uh, field of sustainable concrete and how to relate this sustainable concrete with modern age infrastructure. So, as the theme suggests, we need to connect sustainable concrete with modern infrastructure. However, I have tried to focus on a couple of research initiatives. Those have been taken at the university level, at our own laboratories with our own PhD and master degree students, where we have put efforts to develop the sustainable concrete. And however, the experimental work that we carried out was recognized internationally also. But even though at this moment, I would like to specify and making it very clear that unless we understand concrete and the sustainable terms differently and collectively, it won't give you the complete notion of sustainable concrete itself. So we'll not recognize this, whatever we are going to discuss is as complete or 360-degree sustainable concrete. But we have put efforts, so that I would like to discuss with the people, those who have joined this session. I'm sure it will bring some brainstorming amongst the participants. Since to the best of my knowledge, I know that most of you are the faculty members from the different areas of the our country. So it will little bit contribute to your whatever ongoing projects also, as well as it may give you some insights on how to further extend your ongoing work. So with this brief preamble, let's go ahead and let's see. Before we move ahead, I would like to disclaim the usage of some of the images. However, I have tried my level best to not to utilize the ready-made images, but wherever it was required, I have used only for the purpose of the academic intentions. So we don't claim the property, the IPR, the copyrights, that they are us, and it's truly and surely for the academic purpose. So this is the sessions overview that we can go through. Like we'll discuss modern age infrastructure and their demands. First of all, we need to understand the demands of the modern infrastructure. Then only we can go ahead with the discussion of the material level. Then we'll discuss role of concrete in the growth of the infrastructure, significance of the sustainable concrete, changing roles of the concrete in construction, case studies, that means the experimental work which I have planned to discuss with you, current innovations and future research requirements, concluding remarks will be there, and scope of the research and investigations. I have retrieved a couple of topics and a couple of lines which will guide you how to further progress on the research work that you can carry out in the field of the sustainable concrete. And finally, I have mentioned a couple of my our own publications which you can refer. Those are the suggested readings. So when we talk about the modern age infrastructures, the notion of modern infrastructure deals with following things like contribution by the materials, contribution by the methods, present and near future examples, and expectations and possibilities. So let's discuss all this. Like before that, let's have a bird's view on the modern infrastructure. However, we have been in the era of the modern infrastructure since long, and in my opinion, or what I have experienced working while with the material itself, whatever we have been using since last more than 70, 80 years from now, we can definitely categorize all those materials as the modern material themselves. And we can say that it is a modern material itself and the modern infrastructure, because the primitive use of the materials and the system were very specifically non-technical, or we can say that they were simply built in a way in which they were required, like caves and simple arrangement of the stones and all, or the wooden pieces. So altogether, they were very primitive and non-engineered. So the moment when we started actually building the engineering structures with engineering senses, that created the modern infrastructure itself. So we should not claim that whatever right now we are doing is the only modern infrastructure or is the only modern construction material. So it will be injustice to the efforts done earlier. So I would say in last 70, 80 years, we have been working with modern infrastructure and materials, but definitely there is always a scope of progress and scope of advancement in the information and knowledge with which we progress every time. And we keep on adding, being an engineer, we keep on adding latest innovations and available technologies to betterment of the existing practices. And that is how we develop the entire scenario of development and the modernization. So these are some of the examples of extension, I would say, of the conventional practices. Earlier, we used to have the roads on the floor itself or the ground itself. Then we started flyovers. Then we again went for the multiple lane flyover, and then we started building the multi-layered roads or roadways also. Similarly, sometimes we understand that the structures are not built for the sheer or exclusive point of view with exclusive usage. But largely now the time has come where we construct the structures with multi-purpose functions. So more than a one task is always associated. Like here, this is an example where we can see the railway tracks as well as the roadways are connected together, built together, created together to occupy the same space, but to facilitate different or varying modes of the communication. So this is how we integrate the technologies and the way of working with the same structure. If we largely see it's a bridge only, but it's serving more than one purpose of the function. The ultimate examples will be this. Let us say this is a illustrated view of the gift city, which is getting shape currently Ahmedabad, Gujarat area, Gandhinagar area. So here we can see that when you combine technologies, when you combine construction methods, when you combine new materials and the concepts of, let us say, management, environment, sustainability, when somebody wants to put everything together in a way that it fulfills most of the requirements of the current times. So these are the examples, I would say, that these are the best examples of creating the sustainable cities or the modern infrastructure or the combination of thereof. Right. So these are some of the images I wanted to just share with you, which gives us the connection with the modern infrastructure, what we expect and require. So ultimately, what is a modern age infrastructure we can refer to is when the construction or structure gets transformed into a new form, different scale, multi-purpose applications from a common facility meets the requirements of better living standards and technologically upgraded and environmentally accommodated. So when we club together many things like what I have tried to mention over here, which makes the modern infrastructure and it may get developed eventually. So it's not an instance that whatever you create today is going to get registered as modern structure or modern material. So it is a process, it is a scenario, it is a trend, I would say, of construction and research and innovation, which happens in the material world, where we start connecting ourselves with the sense of modernization. So it may not be completely a modern structure because, of course, we have to utilize some of the conventional practices, some of the conventional materials also. However, the treatments may be changing, the scales may be different, as well as the overall, let us say, environmental impact or environmental awareness, which we develop during the construction or after the completion of the structure, that makes the difference between the conventional structure and modern structure. Nowadays, you may have come across to many of the fancy words or let's say trending words like green buildings and sustainable buildings, or the green concept in the in the construction itself, so in the material itself. So all these things actually are the trends that we see around us. But practically speaking, uh, when you exactly have some statistics in your hand, and when you have some comparative analysis between the scenario or between the construction, between the utilization, and between the properties of the construction material, then only we can acclaim that whatever you have constructed is really in the true sense, it is a modern infrastructure. So nevertheless, the notion of the modern age infrastructure requires to think about these points, like when we come, we become conscious about the low cost housing, the environment friendly buildings, new and multi-purpose designs, usage of the non-conventional materials, automation of the manual systems, inclusion of the computerized management, large scale structures and composite structures all together creates the modern age infrastructure. So you may have a question that why at all we are discussing this modern infrastructure in this way, because my intention is to give you some points to think over. Like many of us are eagerly working on the material sides, or the on the modeling sides, or on the analysis and design sides, or the repairing and maintenance sides. So all these points actually meets at a same point where we need to think that ultimately, when we create modern infrastructure, what is our future vision, where we want to drive our industry, or where we want to drive our innovation and research activities to a direction which gives us the modern the sense of modern age infrastructure. So that's why I'm trying to combine all these components. Like, for example, when we go for automation of the manual systems, uh, when the sense of modern world itself comes into the mind, when you do something which is not done conventionally, that's it. So the modernization directly starts when you switch on the fan itself is a modernization. But nowadays, when you do it the same thing with the help of your smartphone, again it becomes uh, the new age modernization of the conventional practices. Earlier we used to plan a lot of things on paper. Nowadays we are doing it in the softwares, and even one step ahead of those practices, nowadays we are doing it with the help of satellite and other communication devices, if the scale of the structure is so high or so big. So in those ways, we can relate ourselves with modern age infrastructure directly, right? But the only requirement is we need to look to the things with a different perspective. So let's discuss about how the materials have been contributing to this modern age infrastructure, and why should we discuss about sustainable concrete itself. So following few slides, we'll be discussing about these points. Like the materials have been serving for the strength and safety, creativity in shapes and forms, like flexibility in the analysis and design, improved performance of the structures, combination of materials for extended use and applications, long-term durability, resistance to the extreme environmental conditions. Nowadays, if you go any part of the world, and if you witness any extreme weather conditions, like whether it is a extreme cold or extreme hot area, you will find at least some structures over there. That means we have already won the battle, or we are already in that way of fighting against these extreme environmental conditions by using proper materials for the construction. So we are already in the modern age area, and we have already developed the modern materials. So that doesn't mean that everything is now to be stopped, but there are always some gaps, there are always some possibilities and potential for the research and development activities that we can carry out with the help of the modern materials which we are right now using. So just for the example, like how we have transformed our conventional to the modern material as far as possible. So we have been using the conventional coarse aggregates like pebbles and river developed the natural aggregates that we have developed. And nowadays we are using the expanded clay aggregates for many of the applications. Like conventional river sand is now being replaced by the manufactured sand. Then we have been using the conventional concrete. Now we are using the fiber reinforced or many similar other modified concretes. Now we have been using the multi-layered timber structures or timber elements instead of the conventional timber or wood. So these all are some of the examples of the transformation of conventional material to the modern materials. Similarly, the conventional methods to the modern methods, like earlier we used to have these timber planks and timber formworks, and now it has been replaced with the steel members or steel structure itself. nowadays, if we go one step ahead of this old technology, we know that with the inception and the starting of the lighthouse projects in India, and now we have come to many of the excellent construction practices. And one of the projects which fortunately going on in the R city, that is in Rajkot itself, is just relating this conventional practice into the modern practice, that is the tunnel formwork shape, right? So that is the technology that has emerged now. So in short, we need to understand the second the image shows that conventionally we used to build the buildings like this. Nowadays the prefabricated structures are available, the modular construction is available, and easily you can erect them within a very less time compared to the earlier construction practices. So these are the examples of the transformation of the material which were conventionally used, and now they have been utilized in a modern pattern. So let's discuss something on the demands by the modern age infrastructure. Definitely, when we say something is getting modernized, then itself it will be requiring certain points and certain facilities. So what are those things we need to understand? So first is fast construction. That is a primary demand of the modern age infrastructure. So by using the blue figures that you can see on this slide, actually answers to this demands, or examples through which we can satisfy these demands. Like fast construction can be satisfied with the modern methods of construction. Sustainability is one of the demands. So if you use the various waste, I'm not going to point out a specific waste at this moment, but whatever which is a waste, and somehow if you can use them into the construction activities at a material level, at a system level, at element level, then you can contribute to the sustainability definitely. Innovative materials, like you need to do a lot of research in chemistry basically, because it's a nice way of integrating nowadays civil engineering and especially the material engineering with the chemistry, because chemistry is a base of any of the material formation. And if you go into the detail, if you chat with your people, those who are specialized in chemistry and chemical chemistry itself, primary chemistry, then definitely you will learn a lot of new things about your very own favorite material itself. Let it be a stone, let it be a timber, let it be a concrete itself. So if you do a lot of research and innovations, definitely we can create innovative materials. Then another demand is a simplicity in the execution. Like, for example, if we go for the modular construction, it's very simple by principle. It may look complex because the scale is very large. The instruments that we are using are very gigantic. But on the other hand, if you take a planar view of these activities, you'll ultimately find that it's very straightforward, very simple, very non-complex type of the system. Like, you need to bring your modules at the site itself. You need to just use some fabrication methods, and you are done and very good to go with the usage of the structure. So in this way, we can say that simplicity in execution is a requirement or demand of the modern age infrastructure, and we can satisfy it by using modern methods. Then efficient handling and management, that you can do with the digital controls, right? So with the digital control, I would like to say that by using some softwares and some of the techniques and methods, right? So the efficient handling is very much possible using some softwares and some packages where you can have a better control on usage and management of the activities at the site. New machines, new methods and equipments, definitely we are dependent in this case to the mechanical engineering progress or machines. We are largely dependent on that, and you may have also noticed that repeatedly we have been coming across to the new equipments nearly on a regular phase, like the cranes and whatever the big instruments are getting evolved from the mechanical side. So these are the ways to satisfy this demand. Then futuristic vision and long-term planning. So you need to focus on urban planning for this. And with the notion of the urban planning, we need to take into the consideration of lot many other parameters like better housing possibilities, better facilities of the primary services, then the environmental impacts also, then the life cycle assessment and of the material or of the system that you are utilizing. Everything is an integrated part of this futuristic vision, right? So skills, capacities, and knowledge. So these are another way of having a demand from the modern age infrastructure, and that we can satisfy by giving a training, by developing the people with spatial skills and spreading the awareness and organizing the workshops on the modern methods, so that we can definitely fulfill the demand of this new age infrastructure. Research and development, that can be possible by funding and facilities. So this is a kind of very critical point which we are going to discuss. Like, unless you have good facilities like testing facilities and space and freedom of exploring new things, as well as the most importantly the funding opportunities that you should have, only then you can get inspired to do some research and development activities, which are the base, I would say, which are the base of the modern age infrastructure. Unless you do research and unless the laboratory work comes out of the laboratory and getting started implemented on the site, then or getting it publicized or getting into the let us say industrial format, then there is no point of doing research and keep researching on modifying on the same thing again and again by simply adding some few elements and few materials into the conventional materials. It will never give you the ultimate stage of the modern age infrastructure. So funding, facilities, and industry integration is very much required to satisfy the demand of the research and development. Finally, interdisciplinary work. This is something I would say again a very important aspect. If you want to satisfy the requirements of the modern infrastructure, you need to come out of your offices, your own branches and your own programs. You need to meet people. As I give one example, that you can when you start discussing the things with the chemistry guy or chemistry person who is expert in the area, you'll come to know about so many interesting things about your very own favorite material or the system itself. Similarly, if you start getting in the conversation with the people, those who are from the computer background, those who are from the electronics and communication background, you come to learn about sensors and other development activities in the field, and then it will give you a vision that how you can relate yourself with the existing knowledge that you have and how you can blend them together. All right, so let's focus now on the sustainability and the material innovation. Why material innovation? Why should we do material innovation? Like for the complex, please understand this, all the discussion that we are going to or we are doing right now are only with the context to the modern infrastructure itself. So I'm trying to again give you a relationship between the material and methods and sustainability notion with the modern age infrastructure. So please keep in that thing in the discussion and in the way of getting connected with this session. So complex shapes, designs, and forms of the structure, those are very much complex now, or those are very much innovative now, or I would say free form. So when you want to create some different free forms and unconventional shapes, you require some outstanding materials. The very good example I would like to take it in the same is the Narendra Modi Stadium that we went through in the earlier sessions, where you may have noticed that there is a unique shape, there is a unique requirement of the material and the system. So people have amalgamated, I would say, they joined the materials in a different perspective, like there was a concrete, steel, textile, fibers, lot of things were there, right? So cables were there. So you need to come across to the material innovation to satisfy these requirements. Then modern analysis and structural designs. So why we need to innovate new materials to meet the requirement of the modern analysis requirements. Like nowadays, you know that there are many softwares, there are many packages, simulation packages are available, those who can help us. But the only thing is, unless you develop new material, you cannot progress with those facilities, I would say. Right? So that's why it's required to do innovation in material. Expectations beyond the conventional response. So there are always some expectations, like there are multi-purpose notion connected with the same building or same structure, that it will be satisfying not only the way of transportation, but it will also be creating some electricity. In future, it will be possible to install your wind mill on that field or on that track. So you never know, like how to transform the structure which are already constructed or which are being constructed, and how you can remodify, redefine them with the multiple usages. So for meeting those requirements, futuristic requirements, you require new materials, and for that you need to keep doing the innovations in the material itself. Then multiple roles and responsibilities of a single structure, and finally the environment concerns and energy crisis. So these all are the inspirational, I would say largely it's a requirement. To meet these requirements, you need to continuously do the innovation in the material itself. Then we should ask another question to ourselves, that why sustainability? Why should we think about sustainability? So these are the points on which we can focus, like environmental conservation is one of the responsibility, I would say, of the mankind, and we need to keep thinking about this. And it has become an alarming situation for each and every human being over here, that we need to responsibly think about conservation, right? So unless we think about it, we'll not get inspiration, we'll not be doing any research and innovation and development. So why we should think about sustainability? One of the major reasons is the environmental conservation. Then economy and efficiency, of course, we need to maintain the economy and efficiency throughout the construction activity, throughout the research and development and innovation. Safety and improved performance, that we should also think about for the sustainability. Then social and economical growth is also associated with this term called sustainability. Consistent and high level performance. Then waste management and reduction of the let us say non conventional, the conventional materials. We need to take care of those things. So this all inspires us how we should think about the sustainability, or why we should think about sustainability. Extension, existence, and survival. These are the three important points based on which we are forced to think about sustainability nowadays. So then the other question, basic question comes, which is, I would say, the major area of today's discussion, is why to focus on concrete then, right? We have been discussing a lot of points so far, that why should we think about sustainability, why should we think about material, and many similar aspects we need to consider. Why we should consider that also we have discussed. How we have related the how we need to relate the modern age infrastructure, what are the demands, that also we have seen. But out of all this, why we should focus on concrete itself? It's not something like which I have worked in concrete, that's why I'm discussing it. However, to support this answer, I have mentioned a couple of points here, and maybe of the interest of many of us, like versatile but conventional. It's a material which is versatile and conventional. So it's a, I would say, I always refer concrete as a wonderful material. So sometimes it do wonders, sometimes it doesn't work at all. So kind of mysterious behavior is always there with the concrete, and that is why we should think about, or we should focus on a concrete primarily. Second is, these are, I would say, the properties, or informal properties, I would say, about the concrete. So timeless. Concrete is a timeless. If you go back into the early days where Romans and Greeks started construction, they also informally developed the concrete, and nowadays also we are doing concreting. So it is timeless, like it never gets old, or the old construction practices related to the concreting or concrete technology. So it is a, I would say, evergreen material, which you can use with some, or definitely different modifications. We can definitely use them in the different ways. So that's why we should focus on concrete. Then it is highly accommodating. I have never seen, like, or if you may have come across by chance, like, how many of us have seen that the alloys and the other metals have welcomed the addition of the fibers within them, and surprisingly they have started performing well. Or in case of the timber, or in case of stone or sand and everything, when you start adding new things together, it's like our body is readily available to accept all the external things inside, right, without complaining much, unless and otherwise it is very harmful in other ways. So similarly, concrete works very wonderfully in case of accommodating the new materials, or the external materials which are not actually chemically or physically the part of the concrete itself, but even though it works well. So it is a very cooperative material. So that's why we should focus on that. Then suitable for mass and mega structures. I would say that when you require a mass, you may not be thinking about any of the steel structures, any of the other materials, but you will be thinking on the concrete itself. So where you require mass, like dam structures and heavy structures like flyovers and all, or multi-lane flyovers or multi-level flyovers, definitely we first of all think about the concrete itself. Then the mega structures, like large scale structures, we can definitely construct with the concrete in a better way. That's we don't need to prove it, but because we have been noticing that from the past or till date, we have seen mostly of the mega structures are constructed with the concrete itself. Right? Then the energy intensive, these are some of the things which were in the favor. Now we need to look against of the concrete, and that is why we should focus on concrete. So I have mixed the points together, which are in the support and against the concrete itself, and that is why these are the reasons why we should focus on concrete. We all know that it is extensively being used. However, it is highly energy intensive. We all know that because of the cement and all other activities and transportation and many of the things. We are not going into those details, but ultimately we know that the concrete and its production, its manufacturing, its transportation, everything is so energy intensive. That's why we should focus on concrete. It's something like, if something is being used extensively, we will definitely require it to be very efficient and cost effective together, and also the environment friendly. So that is why we should focus on concrete. It's difficult to recycle and reuse. We all know that, though the research is going on in full-fledged, and we come across many research papers also where people have started using the recycled concrete in many of the ways, and some may have developed the methods of getting the let us say the conventional material out of the hardened concrete pieces, and all these things have been practically done in the laboratories. But even though, I would say, still it's very difficult to recycle the concrete, because the recycling notion is completely different, and the reuse is nearly very difficult, right? So that is why we should focus on concrete. It's misdirects itself, as I said earlier, and susceptible. You never have a full confidence because of its one of the requirement or one of the property limitations, like it's highly permeable. So there is always a susceptible material that concrete it is itself. So that's why we should focus on it. Then ready to use but difficult to predict. Similarly, if you have foolproof your designs, you have foolproof your mixes and mentions that these are the proportions to be used, this or that, everything is clearly instructed, even though sometimes the concrete doesn't behave in the desired way. So it's very difficult to predict because of the other limitations other than the designers inside. Like there are some practical issues, you forget to cure it, you have not properly vibrated it, or the formworks was not aligned properly. So even if the foolproof design is available, there are always some problems with the concrete about which you should focus. Then weakness by virtue, as I said, it's not capable to withstand against the tensile forces beyond certain limits. So these are some of the basic laggings with the concrete already existing, and that's why we should focus on concrete. And finally, common or obvious choice for the construction. So this is again in a going in the favor of the concrete. So it's whatever with the limitations, whatever are the challenges, even people will definitely think about the concrete being the obvious choice for the construction, right, all around us. So this is how we can, these are the reasons and these are the points for which we should focus on the concrete itself. So again, these are some of the points which discuss about the why to focus on concrete. Like concrete is an energy intensive material. Again, cement is a basic, we so far we have not discussed it, so I'm mentioning it again. Cement is a basic material for concrete, but emits pollution and all. So that's why we should start thinking about replacing it again with the some alternative possibilities of the material. Largely, concrete is a non-reusable, we have already discussed. Difficult to obtain the used material and their in original form. That is what is the main concern of this material itself. You can definitely break it into the pieces, small pieces, smaller pieces in a powder also, but it's never free out of the impurities, definitely. So that is one of the reasons that you should focus on concrete itself. Extensively common and cheaper option, so obvious choice, that's just now we have discussed. So these are the additional points which inspires and encourages why to focus on concrete. Now concrete has changed its role with the time, like concrete as an evergreen performer, that is okay, that's fine, we all know that, but as a threat to the environment is also a fact. So concrete plays many roles or changes, I would say many masks during the over the period of time. Like nowadays it's being a threat to the environment, like using the concrete in a different proportion, right? So as a facilitator for the alterations, so that is a good side. Sometimes it also becomes a multi-purpose material. Nowadays you can, you must be knowing that you can add all the ultra modern age materials like nanomaterials. They are very well getting gel with the concrete, and you can definitely comfortably use them. Then the sustainable material up to an extent. So sustainable, that means you can create a sustainable concrete as a material, definitely. So it's again highly accommodating. So this is how it changes its old face. Then as a companion for the nanomaterials, as I said, it's very good to add, it's very good medium to use nanomaterials and getting the advantage of nano properties as an all-time hit material. So concrete has been changing its role according to its usage, according to its way of usage in the construction over the period of time. So Then let's focus on the developments in the sustainable concrete. What are the primary developments? What is the concept? What is the research activities? Applications we'll discuss in the upcoming slides. So let's focus and let's brainstorm on what makes the sustainable concrete. What are the qualifications of a sustainable concrete? So I have tried to mention most of them, like a concrete, or what we call or what we certify as the sustainable concrete, should be made with alternative materials. This is a primary requirement, I would say. So unless and otherwise you use some modern, again I would say modern means some new materials, some foreign materials which yet has not been utilized ever before, that you can use in the concrete in such a way that it plays an important role to either improvise the property or the reduction in the energy requirements, then definitely it can be classified, it can be let us say put into the bucket of the sustainable material itself. So should be made with alternative material, that is very a primary condition. Then second is should exhibit all the primary properties. It should not happen that many times we come across to some fancy concretes, like some let us say, I would say some materials which are directly added into the concrete just for a notion of getting categorized as sustainable concrete, but it's not completely true, because let's say some materials which require some pre-treatments, so-called wastes, and it requires some pre-treatments, and if you add them into the concrete and then you come out with the solution that this is how we have made the sustainable concrete, it's completely wrong notion, right? So whatever you are doing with concrete, it should be logical thoroughly, and it should also perform well in all the primary properties, right? However, it depends on how we are going to use that particular concrete, right? We all know that lightweight concrete doesn't exhibit the better compressive strength, but its use is different, right? So it's very obvious. Then should consist a partial to full replacement of the cement. This is very, very important point, and we should only categorize those concretes which are either replaced partially or fully in terms with the other materials for the cement, because we all know that cement is highly energy intensive material. So may have waste material inclusion, must have get optimized for the material proportions, should require least energy in production, should be available for multiple applications in the different forms. So all these things makes any concrete as sustainable concrete. I won't say that these are the only criteria, but these are the primary criteria on which you can focus on creating the sustainable concrete. So we may go for the changes in the aggregates and fibers and the other recycled materials. Definitely, when you use them together in a different perspective, in a scientifically proven facts and figures, then definitely you can create a sustainable concrete out of it. And we all know now very well tuned also that why you should focus on concrete and why concrete is being given so much importance. We already have discussed those points. That's why we are focusing right now on the concrete itself and how to make them more sustainable, by what means we can do it. That's what we are discussing right now. So in this session, I would like to share a couple of our experimental work that we have put into the laboratories. We have tried to use the post-consumer plastic wastes in the concrete as the replacement of the natural ingredients. Also, we have tried to use them as a filler material in parallel. And the other aspect of developing the sustainable concrete is cement-free concrete, where we are completely avoiding the use of cement, and we are using the industrial wastes and plastics together into the well-known term that now is the geopolymer. So I will be happy to share our own work with you, just to give you a notion of the sustainable concrete. And before we go for that, let's think about why should we focus on plastic again, because it is very much related to the sustainability notion. Because plastic, we all know that we face a lot of challenges in terms of safe removal and safe disposal and permanent safe solutions for the disposal of the plastic. Similarly, we all know that plastic is a recyclable material, but to an extent only. Beyond that, we don't have facilities to recycle specific plastic types also. And that's why in the present time, yearly we have generated plastic waste equivalent to the weight of the entire human population on the earth. So this is the data which is again itself, let's say it's old by 9 to 8 months from now. So again, this figure must have been increased again, and only the 40% of them are effectively being managed and disposed of. So we should definitely think about relating plastic with the concrete, and both materials are so accommodating with each other that you will see in the future slides that definitely it's going to be a very good combination. The only thing is we require more and more research and development activities on this area. Nearly 60% of plastic waste settles in the landfills or the environment streams. Plastic is one of the most durable material, I would say, with the potential for reuse, recycling, reformation, and sustainable utilization. So here I would like to mention that we see again to the plastic as, I would say, an element which disturbs us a lot. But we see to it because it has not been utilized in the way it could have been. Because as a material, if we think about only a plastic as a material, it's a wonderful material. I would say it's a very good, very strong, very durable material, highly chemically resistive material. The only thing is we don't know, because of the limitations of the research and the limitations of the innovations and the projects, we only don't know that how we can better utilize it into the sustainable concrete or ongoing concrete industry. So we all have some fears, we all have some limitations of the information. Generally, it is publicly shared, generally it's not. So awareness is also a challenge. That is why we hate plastic to an extent, but otherwise it is a very good material and have a potential to be utilized in the concrete and concrete like materials. That's what we are going to see now, like the use of plastics in the concrete, like a few favorable aspects of plastic as a material into the concrete that I have come across that I would like to share with you. Like, it's largely non-reactive to the chemicals, versatile in the flexibility as well as in rigidity, like with the same formation, like copolymer chains in some formats, like in fibers, it's flexible. Similarly, if you go to the impact resistance of the granules, those are recycled from the waste plastic, exhibits excellent rigidity, and you won't get any appreciable reduction in the weight, overall weight, if you go through the tests in laboratory. So we only don't know that, I mean, we have a limitations like how to use them appropriately. Otherwise, it's a good material to be utilized. A good surface adhesion and encourage. Some of the limitations are there, how it is being produced. There are some rough surface aggregates also I have seen. There are some smooth surface aggregates are also have been utilized. So I have come across many of the types of these products or byproducts, we can say, which we can happily use into the concrete. Like, it gives you very good encourage also in case of fibers when you use them. Ductility and tensile strength are I would say extraordinary. We have experimented these things in our own laboratories, and we have noticed that it exhibits definitely in a specific format itself that I will share with you. But in that case also, it is a very good material and holds potential to be utilized in the part of the concrete itself. Then lightweight and acceptable cracking resistance. Again, it's highly compressible. You can compress the fibers to an extreme limit and which doesn't secure any extra space within the concrete mixture itself when you add them. So even the weight is very light, the volume will be large enough or accommodating enough to be used in the concrete itself. So these are some of the good sides of the plastic itself to be utilized in the concrete as a waste or filler material, alternative to selected natural ingredients. So we have tried, we have uh, experimented things in the laboratories whereby replacing natural sands with the artificial or the recycled aggregate granules in different forms. We also have tried to use very fine sand replacement with the plastic powder also. So I must say that we have some sort of work experience working with plastic waste in the concrete, and that's what I'm going to share with you very quickly in this upcoming slides. So granules, when we talk about up to the rough size of the 20 mm or on an average size with the base material of LDPE. Fortunately, we are in a city where in all the industrial facilities are available, where plenty of recycling activities takes place. So we were fortunate enough to have a variety of the recycled plastics from variety of the base material like LDPE, HDPE, PET, and e-waste also. Like chemically treated aggregates hold good adhesion with the cement gel in the matrix. Then the used as a coarse and fine aggregate, there is a flexibility. So these are some of the overall observations which I have come across while using the plastic as a granules in the concrete, like influence on the fresh property. So with the lower density, increased air content, reduced free flow, balling effect, and a lower compaction. So these are some of the significant parameters being influenced by the addition of the granules into the concrete, like influence on the strength. Lower compressive strength is observed, like increased impact strength is observed, reduced flexure and tensile strength. So now by this time we can decide. See, earlier when we used to have some negative results, we used to stop the work on the particular project. So it should not be the scenario here. I would like to say that if something comes in the negative direction, that is good again. At least you come to know that this is the influence of the particular material that you have obtained, right? So never stop your efforts. I would say here that even if you are working with some let's say innovative material, not necessarily the plastic, even some other materials like crumb rubber or any basalt fibers or whatever you take, and if you are not getting desired result, don't stop your work. Keep working, and something will emerge out from that work, that at least some knowledge based you have prepared and you are sharing with the international community. You are saying that don't do this, so at least that notion is created. So in short, whatever you do as an experiment, never stop it. Influence on the durability properties. See the increase of the toughness, reduced chemical impacts on the matrix, reduced abrasion, increased permeability. All these properties are favoring the use of the concrete. The only thing, I mean, plastic in concrete, the only thing is where you want to apply this concrete. That is most important. Definitely, I will not advise to use the granules of the plastics in the structural components, those who are facing the direct loads, but at least you can use them where the direct load is not acting, or you can say that the components which are below the ground level, you can definitely use them in the lean concrete, and why not to utilize them over there? Because ultimately it reduces the permeability also, it improves the abrasion and toughness, and most importantly the chemical resistance. So all these benefits are already lying there. So these are some of the examples. As I said, there are some smooth surface recycled aggregates, and there are some rough surface aggregates also. Then we come to the shredded flakes and fibers, like this is on which we have worked a lot, like with the different base material like LDP and HDP, definitely PVC and all. But more importantly, what are the influences on the properties, like interrupted free flow and reduce the slump, congestion for the self compaction, insignificant up to 10 to 15% that we have observed. Influence on the strength properties like significant on the compressive strength up to the 15%, marginal improvement in the tensile strength, and 10% insignificant improve in the flexural strength. But as far as the durability is concerned, increase the toughness, reduce the chemical impacts. And again, the similar behavior that we have noticed in granules, flakes or fibers again contributed in the same way. So this is, I would say, fibers, images of the fibers that we have used in the concrete. Like powder, when you are going to use recycled plastic powdering, making the sustainable concrete material influences in a different way in the fresh properties like reduction in the mixed design, reduction in the mixed density, insignificant on the fresh behavior to an extent, so we can definitely promote it. Like on the other way, improvement of the compressive strength, significant improvement in the splitting tensile strength that we have noticed. So again, we can definitely use this format of the waste plastic into the concrete again as a powder, like. But definitely you require to work upon the optimum contents into the mixed design. Definitely that is a catch of all this work that on which you have to focus. Improvement of the shrinkage, resistance, water absorption, initial surfaces absorption, reduction, all these properties have been observed while working with the plastic powder. So these are the images. And now I'm going to share a couple of images with you through which you will understand how we have worked in the using the plastic fibers. We largely worked on the metallized plastic. So where the well-known wafer pouches that we come across in a large quantity, huge quantity, abundantly, we throw into carelessly, we throw into the environment streams, and that creates a problem. So we picked them up. I mean, we started working on that, and we converted the films into the fibers by shredding, and then in varying form and formats, we started using it into the different proportions in the concrete mix. And this is how we also have tested them at our own laboratory. Like we tested earlier, I said that they exhibit excellent properties. Like this is, you can see, we have measured the direct tensile strength of the metallized plastic, and we ended up to the 1000 Newton per mm. So that was mm square. That was the property that we have noticed. Like again, the thickness is very small, and we can see other forms of the fibers that we have used over here. We have shredded them into the various fiber sizes. Fortunately, as I said, we were fortunate enough to have different size of screens. Now, this is one of the challenges that you may be facing in your area. I'm not sure that how to get the fibers commercially made available from the West. So you just need to visit the industries, you need to contact them and explain them that you require different size of the screens of the shredder machines, because shredder machine is not something which is very rare. It is largely available, but the only thing is you need to have little customization in that way. So if you change your screen size, you can definitely have varieties of the sizes. This is what we have used as a, sometimes we have edited them as a flakes, as a fiber also. So variety of the shapes and aspect ratios we have utilized to understand how to best utilize waste plastic, this particular plastic in the concrete. These are the some of the statistical data which may not be of interest of everyone. So I'm just going through that very quickly. Like these are the properties on right hand side. You can see the large properties of, the common properties of the metallized plastic. Then how we carried out with the mixed design, that this is one of the examples of the mixtures that we have utilized, and we maintained the water cement ratio as 0.45, and we tried with variety of the types of fibers like fiber A, B, and C, and sizes were varying in terms of length. We varied with the aspect ratio in that way. Also, we tried with the varying the proportions or the fractions of the plastic fibers into the concrete equivalent. You can see the weight also, like if you add typical metallized plastic fiber up to 2%, it weighs around 18 to, let us say, roughly 19 kg per meter cube as a quantity if they are of the 5 mm, right? So you can say that 5 to 10 or 20 mm length, we found it workable or acceptable when you are converting into the fibers or flakes. Then these are some of the images. I'm not going to read each and every line here, but I just wanted to show you that it's quite possible to work with these fibers, and long fibers created balling effect. So we should not promptly use those fibers where the workability is of prime importance. For example, where the dense reinforcement is placed, we should avoid using these things in the practice or in the applications. Similarly, you can see some of the images that we have tried here with the addition in the concrete, and we can say that these are the results of the compressive tests and the toughness test and the flexure. Again, you can see that what we noticed that again, even if you add the plastics as a fiber form in the concrete, it doesn't change the primary behavior of the plain concrete. Like failure was again not an elastic failure, it was just a ductile failure. Pardon me if I'm going into the so much of the detail of the material behavior somehow, but it is important to discuss with you all because you will be also working somewhere, some extent in this area. So it will be interesting for you. That's why I have included all these things here. So this is again the using the flakes, and we tried to accommodate the flakes inside the concrete as a beam, and we wanted to see that whether it changes the primary behavior of the uh, ductile behavior of the concrete itself, and we noticed that no, it doesn't contribute in that way, in desired way. So see, all these investigations, I won't claim that it was done very first type in the entire world. So many of us have already worked on this, but it's all about getting to know about these facts and publishing it with the people, those who are working in the same area. So ultimately it gives some information base to everyone. Like tomorrow or some after some time, you'll also be sharing some special sessions with other groups, so where you can again use these things with them, and you can again discuss these points. This is how we increase our knowledge base, and this is how we extend the notion of the making the concrete more sustainable. So now you have at least some do's and don'ts regarding how to create a concrete as a material in form of a sustainable material itself using this plastic waste. At least since we worked on plastic waste, I'm focusing on that. Otherwise, I know that there are many people, there are many professors and the researchers already in this group, those may have worked already in this area, right? So you can definitely share the things that you may have noticed. I'm not claiming that this is the only thing that we have innovatively done, but the thing is, it's always good to share the information with each other by at least publications means also. Like this is what is the image where we have added fibers in the reinforced concrete beams also. As you can see that it's a loading frame, and here what we noticed that it contributed to a little, up to an extent, like up to within the 10% of the change in the typical behavior of the beam. Like compression zone didn't fail into the catastrophic manner, so it hold or the, I would say, the plastic fibers and flakes showed the capacities of holding the material together properly, even at a higher level of the loading in the RCC beams also. These are the lightweight, I mean light reinforced concrete beams, and we have added the fibers, plastic fibers over there to study the relevance. Again, we worked upon with the chemical resistance, I would say the RCPT, you can see here that rapid chloride penetration test we employed. We went for the acceleration, corrosion, and then we obtained the comparative results using the fibers in concrete. Here you can see somewhere the fibers are visible still, and the surfaces have been damaged, and we compared them with the non-treated, or I would say the control mixes, and we obtained some results in a way that finally we could say that definitely it helps to reduce the chemical impacts and effects on the surfaces. You can see here, this is a sample where the flakes were used while here the fibers were used. So when you want to, what I want to say here is, when you want to experiment, do not experiment on a single parameter. Always include multiple variables, as many as possible, in your experimental work. So that is what we have tried to include. I'm sure you may have been facing some background noise, but they are the students, so just bear with him for a while. So I was saying that definitely we should extend our variables as many as possible within the same working group, so that you have a better control and better comparison and better insights on the material behavior. Like then you come to know that okay, plastic fibers may not be favorable to be used as fibers for the chemical resistance, but when you use them as a flakes, they perform well. So at least this kind of things you can discuss. You can have in your hand as a concrete information in your hand when you are working with use of the particular new material into the concrete itself. Then we also tried to develop some analytical modeling on the use of the fibers and flakes in the concrete, and we ended up with some of the good observations. Like usually we have a idealized design curve that you can see here, like we normalize the stresses and strain values and develop the equations. Like we compared it with the other existing popular equations like Hognestad equations, and then we try to put our values and our results over there and try to run it, and we come to know that there is a definitely a linear behavior up to the failure or up to the extreme strain values, stress values in the concrete when you are using fibers in it of the West plastic fibers. But then there is no significant change beyond the crack. Once the concrete has cracked, it doesn't really contribute to the ductility portion of the concrete, and it fails again the nearly in the catastrophic way itself, right? So this is how we have studied it. So these are the significant outcomes. I would directly go to that. Like the experiments revealed that the addition of up to 1% of the metallized fibers up to 20 mm length remained influential and beneficial for the addition into the conventional concrete we are discussing. And plastic fibers quantity is about 10 kg per meter cube for the unit volume of the concrete that you can definitely utilize if you use 1% even. So however, the for the non-structural applications, the quantity may be increased up to 16, that is 2%, double of that nearly, and that up to 1.5% you can go to the addition. So if you have this kind of handful of the information in your hand as a concrete information, proven information done by you only, and when you compare these results with other international work, definitely you can come to a very confidential statement, like you can definitely create sustainable concrete out of using the West plastics and other West products also. Quickly, we'll go to the geopolymer concrete also, like where we completely don't use our conventional cement at all. Like we use fly ash, sodium silicate, sodium hydroxide, sand and aggregates, which are earlier where we used is where the conventional. Now we have started using the expanded clay aggregates also, and manufactured sand also we have started using it. And definitely water is required, but it's of a very small quantity, very small quantity, like up to 1 to 5%. of the total mix, and super plasticizers, silica fumes, GGBFS, that is grounded granulated blast furnace slag, waste plastic fibers, again the recycled plastic aggregates, and we also utilized PVC powders to an extent. So in this, we had some variables like this, a variation of the NaOH molar contents, variation of the alkaline liquid to the binder ratio. Those people familiar with the geopolymer and making the geopolymer, they must be readily getting agree with all this facts and figure that these are the variables. Like unlike the concrete, we have very limited variables, like you just have some gel to aggregate ratio, like the water to cement ratio, and similar other few more. But in this case of the geopolymer, where you are using alkali activators, you have many parameters to be balanced, and that is why we were forced to utilize some modern methods of optimization also, and that is what I have mentioned here somewhere, that how we get inspired to use some modern methods of optimization, and that is how we can relate these materials to the modern infrastructure also, and modern usage of the techniques also. Like conventional mixed design was already there, we tried to follow it, but ultimately we had to go for a Taguchi method, which is one of the popular methods of the statistics, where you can optimize your proportions. And I'm happy to share that we have reduced the trial and error portion of getting the desired mix from the geopolymer particularly. You can definitely use Taguchi for the conventional mixed trials also. There's no doubt about it, because it's after all a very foolproof, well-known method. But the thing is, you have to relate. You have to go beyond some of the your insights on the statistics, insight on the typical working styles, and you need to go to the other people. As I said earlier, you need to meet them, and you need to understand some of the possibilities, how you can improvise on your own hand with the help of all this knowledge base. So we tried with that, and we could definitely reduce the trial and errors to extent, so you don't need to create actually all the mixes and keep on casting everything together and waiting for the results to come. You can go for a single line mixture, which is already optimized, done by the Taguchi method itself, and you can confirm that particular prediction with the help of experimental result. These are the methods. Those who are very well known to the this particular concrete, they must have seen this kind of curing earlier, like, or may have worked along with, like you need to give external heat, but now we have started producing the geopolymer without giving any additional heat for the curing requirement and polymerization. So we have started using GGBFS silica fumes in the alkaline activated concrete, so which doesn't require neither the steam or the thermal curing itself. At a room temperature, you can develop this concrete undoubtedly, right? So with the same, I would say, with a better strength properties and durability properties. So these are some of the tests that we collaboratively did with the R laboratories and with the concrete laboratories at the ND Engineering College, Ahmedabad, and collectively my students worked over there. Their student also worked over there on a common material. So this is how we started practicing, doing the experimental work collaboratively, and we come to know that what are the good side and the limitations of this particular material, even if we use plastic waste into this material. Again, this setup, you can see that again it's a accelerated corrosion test which is under action, and the samples are of the geopolymer concrete itself, and possessing some plastic wastes, right? Then this is an example of the reinforced concrete that we have, and we are using it into the laboratory. This is our own laboratory where we have tried to relate usage of the, again similar to what we did in the concrete, conventional concrete. This is what is the geopolymer concrete beam, RCC beam itself, and possessing some fibers contained, that is recycled plastic fibers, and the test is under the action. These are some of the results. Definitely slump of the freshly made geopolymer, compaction factor, then compressive strength, splitting tensile strength of the mixtures. You can see here there are variety of the molar content, there are variety of the plastic ratio also, like alkaline liquid itself we can produce in many varieties and proportions. Like, so earlier workability affected by the fibers, however, definitely it was expected and it behaved in a same way, like the compressibility of the fibers into the concrete. This was a similar response as in case of the ordinary concrete itself. Then fibers improved the strength. That's what we noticed. And so takeaway is to understand the importance of the intermolecular bonding of the improved density of the matrix in case of GPC, that is geopolymer concrete. Friends, pardon me that if I'm going too technical and may not be able to give you all the technical informations together because of the limitations of the time and context. Rather, I would say I just wanted to give you that how you can connect your research and innovations in the contributory way to develop the sustainable material. And sustainable material, ultimately we have already discussed that how important it is for the new age infrastructure ultimately. So somehow this we are creating or sharing the information. This are our own experimental work that we have come across. Maybe you people are already working in the same line of action and may have different obtains or different objectives that you have satisfied with your works. Definitely, I would love to have your results also and discuss with all. I'll be sharing my email address with all of you at the end of this session, which you can note down and we can start sharing the things together. Like we have already developed some of the stress and behavior, and we tried to map it with the typical behavior. And we produce some analytical equations also, which I think will become too technical, so I have not presented it over here, but we have tried to develop that also, which relates different parameters together, which can predict the behavior of the stress strain relationship of the geopolymer concrete using the plastic fibers. This is what is the result chart, which discusses about the loading as well as the relevant deflection that we have also measured consecutively at the time of the loading itself, and which also says that the impact of fibers on the load carrying capacity of the reinforced sections. Elastic modulus were also obtained, and it was revealed that for a given reinforcement scenario, namely under balance and over reinforced that we tried with, the fibers contributed to the improved ductility, ductile behavior to an extent. I would say it doesn't convert it into the elastic beam, which is not possible, but up to an extent within the scenario of 5%, 10%, and 50%, definitely 15%, definitely the load carrying capacity was altered, like I would say was improved to an extent, right? So if you have some base information, definitely you can then focus on the increasing that potential or that capacity of a material together. This is how we use the recycled aggregates and powder form in the geopolymer. I may not be going into the much details, but I will share these images with you where we used recycled plastic materials in the geopolymer, and we tested. One of my PhD student, Mr. Shemal, worked upon this project and have retried the results what was desired, and we revealed that even if you use the recycled plastic aggregates, they don't get break just like the conventional aggregates under the impact effects, right? I'm not sharing into the detail, but I just would like to mention that it holds a potential. That's what I said earlier also, like we should not start it hating the plastic as a material, but definitely it holds a spatial potential if you use them in a proper way, right? These are the impact results, which shows that definitely the HDP and powder and how the plastic granules performed in the test, and up to the replacement of the natural sand and natural aggregates. Definitely plastic granules performed well in this case. These are the compressive strength test results with the replacement. Similarly, the tensile strength test results, softivity, that also be cross-verified by adding this. And I must say that it retained the strength, not only the strength, but also contributed to the reduced ingress of the water and chemical inside. So these are some of the takeaways on this experimental based work, like the addition of plastic waste in the concrete performed with better capacity compared to the cement-based concretes in general. So sustainable concrete by virtue represents a denser mix and therefore better strength and durability properties. So we should not stop working with plastic as a waste material to be added into the concrete. Don't take it in a way that now people have worked so many things with the using plastic in concrete. If you even paste these keywords into the Google Scholar, and if you start generating the database, don't take it in a way that no, people have already worked on that, what should I do now? So don't even think about it. Your results are ultimately going to be your own experimental work. So never stop experimenting and keep working on the and building the database. Ultimately, what you'll be doing, you'll be using different forms, different proportions, different mixtures of the plastic granules, plastic fibers, and some people have also used plastic mesh itself, like they have developed the wrapping element out of the waste plastic also, then they have tried in the concrete itself. So there is endless examples we can discuss, and you can find on the internet sources also. Like never stop yourself and keep developing some informative database, so that you can better communicate with people, you can produce them internationally, and you can come to know that this is the real potential lying with very I would say hated materials like plastic, but still you can use them in a way that they don't harm actually the core concrete component, but definitely you can utilize them in a very sensitive way otherwise, right? So I'll not be going to word in this case, but largely I would say this is what is the outcome or takeaway from this discussion, what I experimentally discussed over here with all of you. Now, some points are required to be discussed quickly in terms of what is the significance of the sustainable concrete, why we should use them again to utilize the waste materials. The method of concrete making also get inspired and change. You should also inquire on the life cycle assessment for the sustainable concrete, and the natural raw materials may be reduced or mitigated to an extent if you start working on sustainable concrete. And what are the areas which are against in the use of the natural raw materials, like once they are used, they are difficult to obtain in the original form, right? This all basis why you should create the sustainable concrete. Limited availability in nature, like we know that we cannot produce the same limestone, right? So we should start thinking over it. Difficult to recycle and reuse for new material production. Always they create a problem, challenges, irrespective to whatever you may have done or you may have come across or you may have read, that now this is possible to use recycled concrete into the production of the new concrete. don't directly start relying upon it. And it is my advice, or I would say rather, you by yourself try it at your own labs before emphasizing that yes, it is a very true information and now we should start it. Don't rely upon just because there are many of the limitations, practical limitations, which already are there and going to be there uh, for a long time, unless we use some modern methods of getting the materials in a new form from the used material. So manufacturing is quite energy intensive, and to an extent it is non-eco-friendly also. Like you are depleting some of the material from the nature continuously, and you are not doing anything against of it. And instead of, you are treating something else, like you are growing trees and you are greening the area, and it's not going to compensate the loss. Please understand. So this is how we should not stop here. Rather, this is the right time, and it has been a right time for youngsters, especially those who are here in this group. I would mention that people don't wait and start working on creating the sustainable concrete, which is going to be the major attraction for the upcoming infrastructural age. Now, what are the positive sides of the waste material? On the other hand, they are available in variety of form, size, and shape. That what we have seen, enormous in quantity and available locally also. If you sensibly segregate them, that's again a debatable point, and I will not be going into the detail of that because we all know that we throw plastic, for example, carelessly, and we hardly go beyond that point of dustbin, like what happens with the plastic. And we all know ultimately it is going to get dumped into the landfills, right? So this is a different point of discussion also, or you can start working on that area also, that how you can do it. But ultimately they are produced in a large quantity, so there is a consistent supply I would say of the waste material capable to get well with the concrete constituents, that what we have seen just now before slides, like they are contributing to the improvised or desired properties can be improved with the use of such waste materials. Not only the plastic, please don't take it in a way that whatever I have discussed is only regarding plastic, it is the only material. No, it's not like that. Please take care. There are outstanding materials like coir fibers, jute fibers, like what people have experimented, palm oil, ash, that also rice husk ash is also used, and people have received similar outstanding results. So don't restrict yourself. I'm not promoting West plastic only, but please, whatever I did, I shared with you, but you also should keep on doing the research in the different ways, like feasible to the waste materials are feasible to use, sourced from the natural waste or amendment waste. So definitely you can have a very good combination of man-made and natural waste materials also, right? Method of concrete making also get influenced, like if the wastes and local materials are utilized in a significant savings of the energy, if possible, pre-treatments to the materials in case of the waste materials may not be required. Mitigation of the wastage of the concrete prepared due to the fixed proportion of the waste plastics then requires energy if prepared with the conventional material. So all these points are connected well with the method of concrete making also to an extent. And what is the importance? I have a couple of times mentioned in this session that life cycle assessment is necessary. So why at all it's required? Like assess the impacts of the utilization of the materials at every stage on the environment, like starting from the quarrying itself to the final end product. Every stage, every minute stage is full of energy and energy utilizing. So if you even don't want to get into the material exploration, you can also get diverted towards the life cycle assessment. And friends, let me tell you, we have suffered like anything while collecting the data based on life cycle assessment when we wanted it. So we had no any other option but creating it. So we started also, a couple of my students have already worked on life cycle assessment of the material, and we also struggled a lot getting the authentic data on some of the things. Like even if you use excellent let us say softwares and database available on digital media, like open is a one of the software which facilitates life cycle assessment, but also there are some predefined quantities of the material already available, like how the fuel is being used, how the transportation cost your life cycle assessment. But after all, at some point you need to work on your own let us say materials. Like nobody will tell you how energy is involved in producing the alkali activated concrete, for example. So yourself, you have to start working on it. So this is another way of doing the research in this area also. I just wanted to mention it. Then you can quantify and obtain the overall energy required to produce the unit volume of concrete with the wastes and without waste material, that you can also obtain from the life cycle assessment. Evaluate the recycle, reuse and reduce attributes of the concrete prepared with the and without the wastes, that you can also ascertain. Because to say something confidently, you need to have a comparative analysis and results in your hand, and it will be better that if you produce your own data and publish it, it will be fantastic job. Compare the cradle to grave models of each material. Now the sense of this doing life cycle assessment has changed to the cradle to grave also. So cradle to gate and cradle to grave, these two are the concepts popularly being utilized in life cycle assessment. Whatever is suitable to your own material, you can definitely utilize it. Waste-based concrete, there are some aspects on that. There are various materials I would quickly go through, like you have a fly ash, you have furnace slag, you have silica fumes. Red mud is also a mine-oriented waste, then foundry sand, ceramic waste, marble waste, and many things are there which you can name over here. Construction waste, recycled aggregates used or broken masonry, waste glasses, plastic waste, recycled plastic fibers, recycled aggregates and powder e-waste. This is also an interesting area where you can start working to meet the requirement of sustainable concrete and the new age infrastructure requirements. Rice husk ash, palm ash, and crumb rubber, and things are getting developed continuously, and this growth is so fast. I would say, as I said, I keep on reviewing the papers also, and I many a times come across to many interesting facts and figures, like people have used many interesting things in the concrete. So there are some current trends that we need to go through, like integration of the technologies with the concrete, development in the concrete manufacturing itself. Like let's, for example, let's take it ready mix concrete itself, though it's not too modern, but it's again a change, right? And that's what we have noticed everyone. Notion of the optimization for the concrete, integration of nanomaterials definitely in the concrete. That is right now it's growing like anything. Performance and reliability of the concrete also are some of the trends of research in development in concrete. Recycling and reusing requirements that being investigated continuously, and cement free concrete. These are some of the current trends of research and innovation. So in other ways, if we go through the quickly through the content based products of the concrete, I would say they are the ultra high performance concrete, fiber reinforced concrete. People with concrete background will definitely be aware about all this. That's why I'm not just giving you the names. Lightweight concrete, polymer concrete, self healing concrete, nanomaterial concrete, all this are the constituent based products. Those are under the current or have been under the choices of the researchers since last 5 to 10 years from now. And These are the method-based products which are continuously under the research and development scenario, which concrete with modern enforcement, 3D printing, and concrete canvas, to name a couple of them. So as a reinforcement, when we say people have started using rebars, FRP, GFRP, CFRP bars as a basalt fiber, they are also using this as a rebar. As far as the fibers, natural and synthetic, and nano material as a powder form, these all are under the research and innovation components, like you can see. And I'm fortunate enough to witness some of the tests done at our own institute. My friend and good friend and colleague Tarak Vora is working on this area. So we come together and frequently we discuss about all this, how we can utilize GFRP and stirrups as a bar. Basalt fibers are also utilized by us, and this experimentation is going in a full swing in the current time. We also have experimented with cotton fibers and jute fibers and core fibers from one of my students, and a couple of students are already working on this. As far as steel fibers is concerned, the things which I'm discussing are at least 2 years back, where there was a possibility of working in the experimental laboratory setups. Now it has been started and people have started coming in, so I'm very hopeful that same fledge of the work will come together in the laboratories also. Then nano particles are also in way of research and development scenario, like carbon nanotubes are being used. Definitely fine silica is also being used. I've come across many papers, research papers on this topic. The notion of the biomimicry in the concrete is already in a very line of production itself. You can see that the patterns, those are available in nature, is being adapted for the effective use in the concrete. And ultimately the 3D printing that of the concrete, that most of you are already aware about it. And this technology is also emerging, and I must say many IITs are working on this, and they have come across to the promising results also. I forgot exactly the name of the IIT. I think if I'm not mistaken, it's IIT Madras. You can better inquire about it and just go through their innovation or the latest experimental work over there. So this is in the support of the 3D printed concrete, definitely, but still it requires some let us say some database and some innovation part, because if I want to replace the conventional concrete with the green concrete or sustainable concrete in the 3D printing, how it works and how it performs, it's still a not foolproof technology has emerged. So these are the areas where you can work, but definitely it can contribute to the at least the modern age infrastructure ultimately, because it gives you a freedom of the shapes and sizes. And it's quite possible to produce it in the on the commercial basis also. With the definitely it requires different set of the modern infrastructure and supporting the supporting framework for this particular implementation of 3D printing. So finally, there are some challenges definitely against the sustainable concrete. Again, I'll return to the concrete as a term. So we don't have like acceptance, direct acceptance from the industry or commerce. From the commercial point of view, durability is one of the concern of the sustainable concrete I'm talking about. Feasibility for business model and mobility of the products are some of the constraints from the industry point of view. Then research like standardization, we don't have any actual code on that which is fully developed and published on the sustainable concrete clearly, and prototyping limitations are also there sometimes. And the social concerns are also that, like we don't start believing in the product which are unconventional, like concrete itself as a regular concrete, if we are using, then if somebody comes and gives you kind of plastic aggregate concrete, then people are hesitated still, even in today's time also. So these are some of the social factors also, lack of awareness, lack of local support by the authorities, and many other things are working behind this curtain. And sustainable use of concrete is subjected to all these parameters and factors. But this doesn't mean that you should stop working on development of the sustainable concrete, and please keep on going on with your experimental work, what you are doing right now. So there are some concluding remarks definitely. Uh, the contribution of the concrete in construction we have seen, like it has been contributing since the time immemorable. Modern construction practices and the concrete that we have seen in our consecutive, this discussion, uplifting the conventional concrete, allow, like how we can modify it, that also we have seen the technological integration we have noticed, like nowadays 3D printing is being done. Future trends we have seen, like in concrete as a material must be extended with the increased use of waste material. I have emphasized like anything. I have also demonstrated like how we can use some of the waste like plastic in the concrete. Detailed study of the life cycle assessment will be a key for a successful implementation of the sustainable concrete in the practice. So these are the takeaways, I would say. I won't say these are the concluding remarks, technically speaking, but these are the observations of the session that we spent since last 1.5 hour. So you can say that these are the things on which you should, or all together we should start, thinking and working together. So there are definitely a scope of research available, like new concrete based materials you should investigate, or you can try microstructural investigations of concrete. This is very, very important. I would say people, those who are related with the chemistry, this, if they are not your friend, make them your friend and just start, interacting with them, working on the microstructural investigations. That means the micro level of the material itself, life cycles and the sustainability predictions. This is again a different scope of the study in this area. Use of inbuilt sensors in the concrete. This is very, very innovative, modern, and most relevant area of the research. There's those who are young people, those who are fresh graduates here, they can definitely start working in this area. How you can use the inbuilt sensors inside the concrete and you can utilize it. Monitoring of the concrete structures has been the one of the favorite topics of the research, so it will continue. And effect of severe environmental conditions, again this on the concrete definitely, but on the sustainable concrete, these are some of the scope for research in an investigation in this area. I have put it into the form of the sentences also, like you can take them as a title also for the research that you, if you wish to carry on. But I'll be sharing this later in case if you need, you can contact me. I'll be sharing them with you. Not an issue, but these are the points on which you can definitely carry out your research and investigation activities. These are the suggested readings for you, which we have published definitely with the help of my some of my PhD students, some of my with the my PhD guide also. We have published already. This is available to refer. You can refer them, and here you can see that we have tried to put all the efforts to publicize the findings that we did in the practical approach. So finally, thank you all for your attention and participation. Feel free to be in conversation with me and to collaborate with me and our institute, our university, our department. Will be more than happy to help you. And here, which you can note down my easy email address. In case if you are interested, you can get in touch with me anytime through this email address. So with this, I'm again thankful to all of you for your listening, your participation, and thank you for the opportunity to share some of the work which I had, and I'm sure that you may have find at least let's say 5 to 10% useful information that may contribute to your future work. So thank you all, and thank you this FDP organizers for considering me as one of the speakers. Thank you. So over to you, I think, Hussain, sir.
So thank you, Ankur sir, for such a nice, informative and in-depth session on modern and sustainable construction materials.
Yeah.
So sir, we have 2 or 3 questions with us. So with your kind permission, I would like to take those questions one by one.
Yeah, of course, please go ahead.
So first question is what are the exact properties or the criteria that define the material as a sustainable construction material, and what is the future scope?
Okay, so I think I have clearly mentioned the qualifications. If I quickly go back, whether I'm able to do it or not, I just want to go back to the people, those who are interested to know. The qualifications I have already mentioned as far as the concrete, when we can say it's sustainable, there are some basic qualifications must be there with the concrete itself. Let me go back quickly. I think I have mentioned it earlier, but anyways, let me take a few more minutes. Yes. So when we say, or when we want to say that this is a sustainable concrete, these are the things must be there with the concrete. So I would say the participant will definitely go through this. This list should be made with the alternative materials. Primary criteria, if you are interested to know, I must tell you that there has to be replacement of cement. Please understand, without which whatever you do, it's not going to get certified, even not going to get proved that it's a sustainable concrete, because sustainability primarily works on energy intensity, and that's why whatever material which are fully energy intensive you should avoid, or you should definitely replace. So I think these are the points which qualifies any concrete to be sustainable. So I think.
So next question is which parameters should be considered before replacing any material with cement or aggregates?
Well, I would say in this case, first of all, you should focus on the utilization or the use of that particular concrete for which you are going to produce it. Just I'll give you an example that if I'm producing a lean concrete, definitely I know that there is no point of achieving high or good strength in compression. So there is no point of even worrying about it. You can bluntly, mix your proportions with maximum proportion or whatever waste material you are using in a concrete, and definitely you can produce your desired mixture, right? So there is as such no fixed criteria. You should reach to the single point that these are the criteria on which you will be producing your material, but definitely the primary criteria is the usage or the application. If you are using your sustainable material, definitely in the pre-stressed concrete, I would say, so you should not focus on the other properties, but you should focus on your strength, the stress reversal process, the stress release process, and how the steel fibers and or the fibers which are being used for pre-stress and surrounding concrete works together. So all these things work together. I think I have answered to an extent to this question.
So once again, thank you, Ankur sir, for your valuable time for this wonderful session.
Yeah, thank you all, and again all the best for the upcoming session.
So with this, I would like to conclude the session, and all participants are required to join next session as per the scheduled time. So thank you, sir, and thank you all.
Thank you. Thank you.